Hello everyone, today we are going to solve this question called remove all edges and duplicates in string 2. If you like that content, please like and subscribe to my channel. I post pretty much every day. So you are given a string s and an integer k. A k duplicate removal consists of choosing k adjacent and equal letters from s and removing them, causing the left and the right side of the deleted substring to concatenate together. We repeatedly make k duplicate removal on s until we no longer can, and basically what we want to do is to return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique. Okay, so let's take a look at this example, because I can see that this example doesn't have any duplicates, so that's not really interesting. But if I was to try to apply whatever we want to do, I would try to look for k duplicates, right? So if I can see already that there is k duplicates right here, so I would apply this and remove the three e's. Okay, and if I remove those three e's, I would just get d d b b c c c d b d d a a. Okay. One thing that I can notice already is if I was trying to remove it from the string or any kind of string builder, that would be really a costly operation to remove anything that is not that is inside within and not necessarily like at the end of the string builder. So we kind of want to avoid this kind of approach, because that would bring our time complexity to something like order of n square, which is not something we want to do. So if I remove this and I get these three a's, I again have to remove these three c's. Okay, so this time I'm just going to take this and remove these three c's, and that concatenates whatever was before and whatever was after. That would get us this. And once I have this, again, I can reapply this operation by seeing that I have three b's, right? And these three b's can be deleted by concatenating the previous, and I can see again that I have three d's, and these three d's can be deleted again, which gives us the result, the expected result, which has AA. Okay, so one thing that I can notice already is if k was equal to 1, this question would be way too easy, because it will just be deleting the character itself. So it made no sense, and that's why I kind of understand why they decided to have a value of k which is at least 2. And if k was equal to 2, in that case, I would just try to remove the duplicates and concatenate whatever was before. Okay, so it seems pretty straightforward that you would want to like compare whichever character with like its count, right? But its current count is going to change as you traverse the string, right? So the thing is, whenever we get a count of 3 in this particular example, that is when you want to delete things up. So you still need that information related to whatever has been processed before. So it seems that whatever was seen last has been deleted, and we keep track of whatever has been seen last. So that's kind of like using a stack. So I would push all the characters. As I go through the string, I will push the characters, and if the character that is on top of the string has a frequency count that is equal or greater to k, in that case, that is when I can proceed to make the removals like I wanted to, by popping things out of the stack. And if I pop things out of the stack, I won't lose the information related to what have been seen earlier, which is a good thing, because this way I can build my result after. So let's try to dive into this and code things up. But in short, I want to go character by character. And once I go character by character, I want to check that the character that is on top of the stack has a frequency that is equal to k. That is one we want to remove we want to pop things out. Okay, so I want to pop it like instead of having to pop this like k times, I would just push into my stack the following information. I would push the character and the count. So let's have a DQ with a pair of character and an integer, right? And I will call that a stack. In Java, we use a DQ to implement a stack, but I will limit myself to stack operation like push and pop. Okay, so for each character, I will push into the stack the character and its count, this frequency, and if it's equal to k, in that case I would pop. But what if it was a new character? Okay, so I would say that anytime we encounter a new character, I am going to reinitialize the count to 1. Okay, so if the character that is not on top of my stack is not equal to the current character, I know that I should push into my stack. I should push the pair, which would be the character and a count of 1. Okay, and the last thing that we are interested in is the stack will always have the information related to the character. So at the end, I can build my result using the stack. Okay, so let's try to build these things. Let's have a string builder, which will have my result. And it's actually a string builder. Okay, and like I mentioned, I will go through the string character by character. And at all time, I'm going to check if my stack is not empty. If my stack is not empty, I'm interested in taking a look at whatever is on top of my stack. If whatever is on top of my stack, let's say that the key, which corresponds to the character, is different to my current character, which is C. In that case, I'm interested in pushing into my stack. So I would actually change this to if my stack is empty, or this, because in both cases, I'm going to push into my stack the character as well as a count integer. Okay, and in all other cases, I want to check whatever is on top of my stack. So if at this point onward, I know that my stack is not empty. So I just have to check if the element on top of my stack, let's have stack is not empty. And the element that is on top of my stack, I'm interested in the value. If it's equal, if the character is equal, in that case, I want to push. I want to do two things. Let's take the pair character to integer, and I will call that count or char count, and I would simply pop that from my stack, right? And the char count has to be updated, right? So that is when I'm interested in knowing char count dot key value. I'm interested in knowing whether or not that count is equal. One thing I can do is simply push that thing into the stack again, right? Just having a stack push a new pair with that character, right? And the count +1. And at the end, I'm just going to check whether or not the count +1, my new count, which I can simply increment here. I'm going to check if my new count is equal to whatever k we are looking for. If it is the case, I do know that I need to remove all these elements. So I can pop it from my stack and don't do anything else. And in all other cases, I guess we are pretty much good to go. If it was, I could even change this to just say less than k, because I already popped things out right here. So if it was less than k, in that case, I would push it, right? And I already popped this thing out. Okay, looks pretty good to me. The only thing that I need to do is to build the result now, which can be done by simply going through the stack and checking, popping the elements and appending these elements into my result, which I have a tendency to call SB for string builder. I will just pop things out. And remember that that result is appending things in reverse order. So you kind of want to reverse whatever you got and convert this to a string. Let's try to run this code. And I can see that I'm missing elements simply because I'm pushing. I want the key, which is the character, right? And that would work. All right, so it looks like it worked. Let's try to submit. I have an error, which is because if my stack is empty, get key, which is different, that's fine. So I push 1. And then if my stack is not empty, in that case, I am going to check whether or not the count has a value. I increment the count, and then if it's less, in that case, I will push the character and the count. Okay, so while my stack is not empty, oh, I know why. That is because right here, I'm actually doing something that is incorrect, because I should have taken the pair, let's say character to integer, which I would call pair, and simply pop things out, right? And have, let's say, a count, basically the number of characters, because you have to append as many characters as possible. And I will get the value out of it. And I will simply repeat the append as many times as there are some characters, okay? So I will append to my result the key, which corresponds to this particular character. Let's try to run this. It just doesn't like this because it's get key, and that works. Okay, so let's take a look at this example and see if I have solved the problem, but it should work. Okay, so it looks like it worked. Let's try to submit. Okay, so it looks like it's worked. The only thing that I'm interested in is the time complexity of this problem. So I can see that I have to go through all the string characters for all the characters, which if I call n the length of the string, I would have to go through all of this characters and simply apply these constant operations, which is like pushing and and doing some comparisons, and all of them are constant amount of time. So it's going to be order of n for this loop. And same thing in the worst case, what I can have is all distinct characters. So my stack would be full of distinct characters. And in that case, I would repeat this thing as well in order of n time. So I can say that my time complexity is order of n and my space complexity is order of n time as well. Thank you for watching. And if you like that content, please like and subscribe to my channel. Thank you.